Howdy! This is your friendly neighborhood physics teacher here, and I'm here to review you for your test on Friday, which is over circuits and electricity. So let's just jump right into it. Let's talk about electricity. So it says draw the electric field lines surrounding the electron and proton. Where our electron is negative, our proton is positive. So knowing that our electron's negative, it doesn't want it wants that positivity. It craves the positivity, so it's pulling everything into itself. It's so negative, it doesn't want to be negative, it wants to be positive, so it's trying to pull everything. Now, your proton, they're positive. So they're trying to give their positivity out everywhere. Here, you get a positive, you get a positive. So it's going out everywhere. So it spreads out. Electrons pull in, protons spread out. Now, that kind of goes into number 2. Which one moves out of the atom? So if we think about our nucleus, you have your protons and we have your neutrons in the mix, and that's our nucleus. Well, on the outer, you have your cloud, your electron cloud going on here. So since it's on the electron cloud, the electrons are in the electron cloud, not necessarily part of the nucleus. They're able to move around. So your electrons are the ones that are able to move. So you think about if we took the balloon and we rubbed it on the hair or our clothing, that is pulling the electrons away from your hair and into the balloon. Same thing with the fur or the fake fur and the rods or anything like that. So anything that causes that friction, that static friction, you're pulling the electrons out and passing it on. So 3, when do charges repel each other and when do charges attract each other? So they repel when they're the same sign. So if you have 2 electrons or if you have 2 protons, that's when they're going to end up repelling. But if you have the ones that have these different signs, so 1 proton and 1 electron, that's when they'll attract. So knowing that information, let's see if we can do number 4. If the ball is negative, what charge does, or if 2 ball is negative, what does the W ball have? So we know 2 is negative. So they're being repelled. So we know 1's negative. So if 1's negative and 1 is being attracted to Z, we know Z has to be positive. So if Z's positive and it's repelling X got to be positive. If X is positive, attracting, so that means W has to be negative. Kind of cool, huh? So your answer is negative. So think about that. So if it's repelling, attracting, fun stuff like that. Now, you will be given the formulas on the test. You'll be given the formulas. But the key thing that a lot of people have trouble with is knowing what variable. Now, variable is what's inside. So instead of symbols, you want to call those variables. Variables. Y'all know I can't spell. Okay, variables. And the units is what goes behind the number. So your electrical force variable is Fe, and it's measured in newtons. Your charge is Q, and that's measured in C for coulombs. Distance is little r, and that's measured in meters. Coulomb's constant is represented by a K, and your Coulomb's constant is 9 times 10 to the 9 newtons meters squared over C squared. V, voltage, potential difference, electric potential, those all mean the same thing. It's represented with a V and a V. Current is an I and an A for amps. Resistance is a capital R in ohms. P is power in watts. Time is lowercase t and S for seconds. So this is what goes in the formula. And this is what goes behind the number. So what factors does resistance depend on? So what factors affects resistance? So think about your notes and think about the Play-Doh lab you did. So the big factors is length. So the longer it is, the higher the resistance. So therefore, shorter, the lower the resistance. It's affected by thickness. And the thicker it is, the lower the resistance. The thinner it is, the higher the resistance. Another thing that affects it, let's give ourselves some more room here. So length and thickness are the two things that are mainly fix it. Another thing that affects it is temperature. So the hotter it is, the higher the resistance. The colder, the lack of heat, right? Colder it is, the lower the resistance. So those are the main factors. You have length, you have thickness, and then you have temperature. What is a conductor and what is an insulator? So a conductor, what a conductor does, it lets electrons move through it. So electrons can move. So since electrons can move through it, it helps electricity. Now an insulator does not allow electrons to move through it. So therefore electricity doesn't work. So conductors conduct electricity. They let electricity move through because electrons can move through it. Insulators do not. So keeping that in mind, so why does touching your screen phone work why doesn't it work when you have gloves on? Now they do make those special gloves because I know like it works for me. Well, you have the special gloves. If you just have the normal gloves or anything, it doesn't work. And why don't you think that? Well, it goes into making a circuit. So your finger closes the circuit. It closes the circuit. There's different boards on the screen, and your finger touching it, like I can see those little, that's my finger touching my screen, those little bubbles. Touching it is closing that circuit there, and it can help react. I can move my slide, I can move it up and down, anything like that just by touching the screen. So what variable is constant no matter where you are in a series circuit? So that is your current. Current is constant. That is your I. For a series circuit, now remember your series circuit looks like this. One big loop, okay? For a series circuit, your constant is I. For a parallel circuit, your constant is voltage. That's what voltage, which is V. And your parallel circuit looks like this. The reason your current is constant is because the current is the movement of electrons. If you have electrons are moving through and it's going from the negative to the positive, they're wanting to get to the positive, and they only have one path to take. So these four electrons have to pass through this one, and this one to get through to the positive side. So all four electrons pass through the resistors. So this would be 4, this would be 4, this would be 4. So that's why it's constant. Now your voltage is constant. Oops. Your voltage is constant because they're all connected to the volts. So if this was a 9-volt battery, this one's getting 9 volts because the electrons that are coming from here, so if we go back doing the 4 electrons, some of the electrons are going this way, some of them are going this way, and some of them are going this way. So let's say 1 goes this way, 1 goes this way, and 2 goes this way. Each of them have the 9 volts, but they're only having to go through one resistor. This one, if there's a 9-volt battery, they're having to go through all 3. So this one's having to take up some voltage, this one's taking some voltage, this is taking some voltage. But in this case, they're all getting the same volts. So voltage, you add up for series. For this one, current, you add up. Current, not V. Now, what is the equivalent resistance of a series circuit with resistors 2, 7, and 4? So another word you can say for that is total. So for a series circuit, you just add them up. So your total resistance for a series circuit is R1 plus R2 plus R3. So you just add them up. So it'll just be 2 plus 7 plus 4. You can plug that in your handy calculator, or you can do mental math. Maybe on the day of the test, plug in your calculator so you know that you're doing it right. So you get 13 ohms. Now so again, that just means total. For the parallel, you have to do 1 over your total. So 1 over plus 1 over plus 1 over. Let's give ourselves some more room here. Come on. And so we're looking for total. And so it'll be 1 over 2 plus 1 over 7 plus 1 over 4. Now, you can't just add up the denominators. So go ahead and figure it. So 1 over 2 is just 0.5 plus 1 over 7 is 0.14. 1 over 4 is just 0.25. Now add those up. And you get 0.89. Now you're not done. That equals 1 over your resistor. We don't want 1 over the resistor. We want our resistor. Come on. There we go. My circuits weren't lining up just right. So we need to get our T on the top. So since it's being divided, you can multiply. So 1 equals 0.98 times RT. Now we can divide. So RT would equal 1 divided by that, and you get 1.12 ohms. Now another trick to think about, for your series circuit, your resistor is going to be bigger than all your other resistors. For a parallel circuit, your resistor should be smaller than all your other resistors. So think about that. So which setup, 11 or 12, would the light bulb be brighter? So it'll be brighter in number 12, so in your parallel. And the reason is the resistance is lower, so the R is lower. It's just a better, it's a better made circuit. It's more efficient. What can be a resistor? Anything can be a resistor. A light bulb can be a resistor. A battery does have some resistance. We don't necessarily worry about it, but a battery can be a resistor. A resistor can be a resistor. Wire can have some resistance. So pretty much anything can be a resistor. 15. A microwave draws about 12 amps, because that A is amps, when plugged into a 120 volt outlet. What is the power? So our equation, which you'll be given, is P equals I times V. So our I is 12, our V is 120. We plug that in, 12 times 120. And our P equals 1,440 watts. When we do our givens, don't forget that we have givens. So that would be our I, that would be our V, and we're looking for our P. So what are the symbols for the following circuits? But the main thing you have to know that would be our battery, our switch. That's a switch. We have a resistor, a light bulb. Those are the big ones. So battery, switch, resistor, light bulb. 17. If 2 point charges are separated by 1.5 centimeters and have charge values of 2 coulombs and -4 coulombs, respectively, what is the value of the manipulated force between them? And it gives us our constant. So let's do our givens. So it gives us R, but it gives us R in centimeters. Do we like centimeters? Hopefully you're saying no. So that actually becomes times 10 to the -2 meters. Or you can write it like E -2. And it gives us Q1. Does it matter which one is Q1 and Q2? Hopefully you said no. It gives us Q1 and Q2. And then it gave us our constant. So the equation that we'll be using would be your Coulomb's law constant, or formula. Q1, Q2 over R squared. So we're looking for our force. So our constant, Q1, Q2 over distance squared. When you plug in your calculator, please put the parentheses. E's are a whole lot better. You can get to the E and make sure it's a capital E. It has to be a capital E, not a lowercase e. Capital E by doing second comma. And you need to put that negative on the 4 too. Divided by E -2 squared. So your force ends up being -3.2 e to the 14th newtons. Ends up being your answer. So what does Coulomb's law help us understand? Let's use this equation to look at it. So we have a positive and a negative charge. So this would be a proton. Excuse me. So this would be a proton, and this would be an electron. So since one's positive, one's negative, they are going to be attracted. They're going to be attracted to each other. So basically, what Coulomb's law is, it shows the interaction, or it shows the relationship of electrons, or it shows it helps us kind of better understand how electrons move. So it helps us understand how electrons move. So 19, 2 point charges initially at 2 centimeters apart are moved to 10 meters apart. By what factor do the resulting electric and gravitational forces between them change? So we don't have to necessarily worry about the gravitation, but the electric force. So going back to this equation, equals K Q1 Q2 over R squared. Let's say that our distance increased. So if our distance increased, our force has to decrease because it's being divided by. But we can't forget about that squared. So it's going from 2 to 5, so or 2 to 10, so it's increasing. So your distance is increasing by 5 because you're going from 2 to 10. So 2, if you're times 5, equals 10. So you're basically timesing 5. We can't forget about that squared. So it's 5 squared, 25. So so if it's increasing by 5, your force is decreasing by 25. It's decreasing by 25 because of that squared, because it's an inverse squared relationship. I can't spell relationship, whatever. Inverse squared relationship. So you can't forget about that squared. So honestly, it would be like multiplying by 1 over 25. So what happens when a rubber rod is rubbed with a piece of fur, given the rod, a negative charge? So it's pretty much taking the electrons. It's taking the electrons from the fur. Taking the electrons from the fur. So which circuit is more efficient and why? More efficient is the parallel. And it's because it has less resistance overall. Less resistance. So how is current in a circuit affected if voltage decreases? So we're looking at our V equals IR equation. So it's saying that so if our voltage decreases, that means our current would have to decrease also if our resistance stays the same. So that is a direct relationship. The amount of charge that moves through an electric fan is 15 seconds is 18.25 coulombs. What is the current of the fan? So you're going to be doing I equals charge over T. And you have this is our time, that is our T. This is our charge, so that is Q. So if we plug in 18.17 over 15, so you just plug that into your calculator, and you get that your current is 1.25 amps. So the next two is dealing with a parallel and series circuit. So for a parallel circuit, things you need to remember. Your resistance, you just add up. Current is the same. Voltage, you add up. Power, you add up. And then equations that are constant between both of them is V equals IR and P equals VI. So now, how this is handy is because you can see what's constant, what rows it equals and everything like that. So we can go ahead and put this equals that times that. And we know this equals V times I. Now for your resistance, we're just going to add those up. So we're going to do 3 plus 25 plus 16. And you get an answer of 42. Answer to life. Now we need current. So current just equals voltage divided by our resistance. So that's just going to equal 30 divided by 42. So you plug in 30 divided by 42. And you get 0.71 as your answer. And your current is all equal. It's all the same. So then you can do the multiplying, current times resistance equals voltage. Current times resistance equals voltage for each one. So you're doing 0.71 times 3. That'll get you a 2.13. 0.71 times 23 will get you a 16.33. And 16 times 0.71 will get you an 11.36. To check to see if you did the math right, you can just add these up, and that should give you 30, or about. So you do that, plus that, plus that, and that when I added them, I got 29.82, but that's close, it rounds, so we're good. That has been checked. So now for our power, it's going to be your voltage times your current. So you're going to do 2.13 times 0.71, and you're going to get a 1.51. You're going to do 16.33 times 0.71, and you're going to get an 11.59. You're going to do an 11.36 times 0.71, and you're going to get an 8.07. And then you're going to do 30 times 0.71, and you're going to get a 21.3. And again, to check your math, these should add up. So you're going to do 1 point that, 11, and 8, and you get about a 21.17, so that rounds, and you are good. Woohoo! So we did the math right, and we were able to check it. Yay! So there we go. So that is your series circuit. For a parallel circuit, a couple of things to remember is since your resistance is more efficient, you, instead of just adding them up, you're going to do the reciprocal. You're going to do 1 over. So it'd be 1 over R1 plus 1 over R2 plus 1 over R3. Your current, you add up. So it'd be current 1 plus current 2 plus current 3. Your voltage is the same. And you still have your VIR, PVI going on. So we can make these equal to each other, and don't forget that this is, is V times I. Here we go. Now, remember, your voltage is the same. So we can go ahead and put 30 all the way up. We can put 30 all the way up. Now to solve for our resistance, you have to do 1 over. So our total resistance is going to be equal to 1 over 3 plus 1 over 23 plus 1 over 16. Get the decimal of that. So 1 divided by 3 would be about 0.33. 1 divided by 23 is 0. 4, 3. And then 1 over 16 is about 0.0625. You just add those up. And you get that your total resistance, 1 over your total resistance equals 1.439. Now, what a lot of people I noticed that they were having trouble on the entrance ticket is that they forgot, they're like, but the answer's not there. You're not looking for 1 over RT, you're looking for RT. So you need to remember, you need to flip it. You need to flip it. What you do to one side, you have to do to the other. So you get that RT equals 1 over 0.439. And so your total resistance equals 2.28. So your total resistance equals 2.28. Now we can do our current again, just like we did before, V divided by R. So it'd be 30 divided by what we just got. And we got 13.18, and you just do that across. So 30 divided by 16, you got 1.88, so 1. 30 divided by 23, and that's a 1.30, and you got a 30 divided by 3, which would give you 10. Now you can check it, because these should add up to get you 13, so we can check. So we do 10 plus 1.3 plus 1.88, and that got me about a 13.19. So we did that one correct. And then to do power, we just do V times I, so that would be 30 times 10, just gives you 300. It's a lot of power. So 30 times 1 point gives you 39. 30 times 1.88 gives you 56.4, and then 30 times 13.18 gives you 395.4. To check, these should just be added up. So we're going to do 56 plus 39 plus 300. That gets me about 395.4. Woohoo! We did that one right. So there we go. Now, I will let y'all in a little secret. If you don't like the 1 over, you really don't have to do it. So I'm going to go down here and remake the circuit here. I'm not going to work through it completely because we kind of already did, but I'll show you a little trick. So this is V, I, R, P. Oh, I need one more down, don't I? And so our total resistance, or our resistance was 3, 23, and 16, and our total voltage was 30. Since this is a parallel circuit, our 30s go all the way up. 30, 30, 30. But we can solve for our current. We can go ahead and do that. And again, you get 10, 1.3, and 1.88. And since they add up here, because those are equal, and we just did this. So since these are supposed to add up, you can just do 10 plus 1.3 plus 1.88 and get you the 13.18. And then to solve for resistance, it's just V divided by R. So you would just do 30 divided by 13.18. And you would get a 2.28. What do we get over here? So we got a 2.28. Woohoo! Hot dog. An 8. So you don't have to do the 1 over if you don't want to. There's other ways around it. So if you're nervous about the 1 over, you don't have to do it. And then you work the power just like we did before. So hopefully that kind of guided you in the right direction for the review. If you have any questions, make sure you ask Miss Heath and Miss Verona. And I hope you have a fun time reviewing. You're almost done. You'll see me again for the final review videos. Have a wonderful day. Bye.